So today we're diving into the world of chemistry, but with a twist. It's about a prize, a global recognition, and some seriously cool structures.
Yeah, we're talking about the 2025 Chemistry Nobel, and it's a story that spans decades and continents.
And at the heart of it all are these things called metal organic frameworks.
MOFs for short.
Exactly. So what's the big deal with these MOFs and why did they win a Nobel?
Well, they're not just any structures. They're like tiny, customizable cages with huge potential.
So let's rewind a bit. The article starts with Richard Robson, who was building wooden models of crystals. How did that lead to this Nobel-worthy breakthrough?
It's a classic case of, accidental genius. He was making these models for lectures, and he realized the balls representing atoms were predisposed to create specific structures.
So he thought, what if we could do this with molecules?
Exactly. He started experimenting with diamonds, and that's where things got interesting.
Because diamonds are forever, but they're also tetrahedral.
Right. He created a substance with diamond-like connectivity, but it was mostly liquid. That's where the space came in.
Like Hermione Granger's handbag in Harry Potter.
Exactly. Finite outside, but very large inside.
So Robson created these open structures with channels and cavities. What was their potential?
He predicted they could be functionalized with catalytic sites, transforming substances as they flowed through.
A chemical processing plant on a microscopic scale.
Precisely. But his work didn't immediately spark interest.
That's where Omar Yaghi comes in. He gave these structures a name, metal organic frameworks, or MOFs.
And he called the field particular chemistry.
Yaghi had a remarkable life, growing up as a Palestinian refugee. How did he rise to dominate this field?
He published a series of groundbreaking papers and really pushed the boundaries of what MOX could do.
So Robson laid the foundation, and Yaghi built the skyscrapers.
Pretty much. He took the concept and ran with it.
Meanwhile, Susumu Kitagawa was working independently in Japan on the same topic.
Yeah, he and his team were making significant contributions.
The article mentions that when the Nobel Committee contacted him, he cut them short because he had a meeting to attend.
Talk about dedication.
So what makes MOFs so special? Why are they worthy of a Nobel Prize?
It's their versatility. You can design them with specific properties for various applications.
Like what?
Gas storage, catalysis, drug delivery, you name it. They're like molecular sponges with endless possibilities.
So it's not just about the structures themselves, but what we can do with them.
Exactly. They're a platform for innovation.
The article also touches on the human side of scientific discovery. Robson's initial work was almost overlooked.
And the executive observation that nobody will remember Robson's collaborators, like Bernard Hoskins.
It's a reminder that science is a collaborative effort, but recognition isn't always evenly distributed.
And that sometimes the person who names something gets more credit than the person who invented it.
Robson hopes the next generation of high-temperature superconductors will be coordination polymers.
That would be a game changer.
The article quotes him saying his contribution was more like that of an artist or an architect.
It's a humble perspective on a groundbreaking achievement.
Robson didn't give his structures a formal name, while Yaghi coined the term metal organic frameworks. How important is naming in science?
It's crucial. A good name can help a concept gain traction and recognition.
It's like branding for science.
Exactly.
This whole story highlights the role of serendipity in scientific discovery. Robson's wooden models were just a teaching aid.
But they sparked an idea that changed chemistry forever.
It's a reminder to be open to unexpected insights.
And to never underestimate the power of a good model.